Hello, dear students. I'm Aditya Gupta and welcome you all to this second lecture on the topic of lines and angles. So, in the first lecture, we had seen the types of angles, different pairs of angles, how we name them, etc. In this chapter, we'll mainly be covering the topics of parallel lines and how they interact with a transversal and lines parallel to the same line, correct? Now, in real life, also, several times we often encounter parallel lines. The concept of parallel lines uh, is most often, encountered in the case of railway tracks because railway tracks have to be perfectly parallel. If there is even a slight distortion, the train will actually derail. It will get off the tracks, which is something highly undesirable. So the railway tracks that are laid out, they are laid out perfectly parallel to each other so that the train can travel at a very fast speed on the track, right? So it is very important to make sure that they are perfectly parallel. Similarly, there might be some other examples as well. A very amazing example is shown here in this diagram, where we are shown that there are two of these parallel antennas, and this third antenna is kind of acting as the transversal. So let us get further into it, what we mean by this. Parallel lines, we already know these are lines that do not meet, right? For example, these railway tracks, these will continue on forever, but they will never meet. They're absolutely parallel to each other, right? And what is a transversal? So the okay, one more thing we should see here is that let us read this entire thing. Parallel lines are the lines which do not meet, okay, and they do not intersect at any point, and they will be parallel, okay. And of course, they also keep a fixed distance between each other, correct? Now, what do we mean by a transversal? A transversal is basically a line that passes through both the lines in the same plane, and it intersects them at two distinct points. So first of all, if we talk about, let's say, two different lines, okay, and then there can be a transversal which intersects these two lines at these two distinct points, okay. So what we are saying here is that this is acting as a transversal. Now we want to discuss the behavior, the relationship between two parallel lines and a transversal, okay. So let us have a closer look at that. Whenever we have two parallel lines and we have a transversal, then first we need to learn how to name the angles. So this angle, angle 1 and angle 2, they constitute a pair of corresponding angles. Similarly, so let us write this down, corresponding pair of corresponding angles. So 1 and 2, of course, they are forming a pair of corresponding angles. Apart from this, angle 3 and angle 4 are also forming a pair of corresponding angles. Similarly, angle 4 and angle 5, they are also forming, or let us name it 6, for example. We have already used the number 4. So 5 and 6 also do the same. And finally, 7 and 8, they are also forming a pair of corresponding angles. Now, let us also talk about alternate interior angles. So pair of alternate interior angles. So they will be 2 and 7, 2 and 7. Another one can be 5 and 3. These are definitions, okay? These we should remember that these pairs of angles are called alternate interior angles, corresponding angles, etc. We also have pairs of alternate exterior angles. So these would be, for example, angle 6 and angle 4, and finally angle 1 and angle 8. Why are they alternate? First of all, alternate because they are lying on different sides of the transversal. So they are alternate, okay? And interior means on the interior, exterior means on the exterior of the two lines, correct? That's how we are naming them. We also have a pair of interior angles, just pair of interior. Okay, instead of that, we should say pair of interior angles on same side of the transversal. So what are such pairs? 2 and 3, and what else? 7 and 5. Okay. Now, there are a few theorems for parallel lines. Okay. So if these two lines are parallel and the transversal T cuts the parallel lines L and M, what are some theorems? Pair of corresponding angles are equal to each other. Equal to each other. Okay. This is an axiom, by the way. We cannot prove this. This is a very closely related to the fifth postulate of uh, Euclid that we had studied in the last chapter. So pair of corresponding angles are equal to each other. This is an axiom. Okay. Now rest of the things that we'll be seeing will be theorems. So second, now this is a theorem. Pair of alternate interior angles are equal to each other. How can we prove this? Let us see. So for example, if we take two parallel lines and let us talk about this angle alpha and this angle beta, we want to prove that these are alternate interior angles. We want to prove that they're equal. Okay. So by this axiom, we can say if this is alpha, then this will also be alpha. Why is that so? Because axiom says that corresponding angles pairs will be equal to each other. Of course, these are corresponding pairs. So this is alpha, this is also alpha. Now, what kind of angles are these two? They are clearly vertically opposite angles, right? Because these are two intersecting lines, right? So these two are forming vertically opposite pair of vertically opposite angles. So clearly these two also will be equal. So alpha equal to beta. So hence we have proved that this alpha and beta are equal. Okay. So this is a very easy and direct proof. Another theorem we have, pair of alternate exterior angles are equal to each other, right? Now, how do you prove this? Let's see. So we can say that let us consider these two pairs, okay, of alternate exterior angles. So if this is alpha, then this will also be alpha. Why will this be alpha? Because they are corresponding angles. So, and by this axiom, we know that corresponding angles are always equal. So if this is alpha, this will also be alpha. And if this is alpha, then this will also be alpha because both of these are actually vertically opposite angle, pair of vertically opposite angles. So that's how we have proved that if this is alpha, this is also alpha, and hence the pair of alternate exterior angles are equal, right? Now, apart from this, we can also write another theorem. Sum of interior angles on same side of the transversal is equal to 180 degree. This is also very easy to prove. Let's say we have two parallel lines. Okay, so all these theorems and axioms are only for, they hold only for parallel lines. Okay, as well as their converse is also true, and their converse their converse are also true. We will quickly understand what are their converse, but first let us prove this theorem. Let us say we have these two parallel lines, and let us say we want to prove that alpha and beta, which are basically interior angles on the same side of the transversal, if we want to prove their sum is 180 degree, then how can we do it? So look, by this first axiom, we can say that if this is alpha, then this will also be alpha, because these are corresponding angles. Both of them are forming a pair of corresponding angles. So if this is angle alpha, this will also be alpha by the first axiom. Now, since alpha and beta are lying on the same straight line and they are adjacent angles, so clearly they form a linear pair of angles, right? So what will be alpha plus beta? It will be this complete angle, which is 180 degree. So alpha, since they form a linear pair here, alpha plus beta equal to 180 degree. So that's how we have easily proven this theorem. Now, what are their converse? Look, if sum of interior angles on the same side of the transversal is 180 degree, then the lines will be parallel. This is the converse of this theorem. So are you understanding what we are saying? Right now the theorem was, if there are two parallel lines and there is a transversal which cuts them, then the sum of the interior angles would be 180 degree. The converse is that if there are two lines, there is a transversal such that the sum of interior angles on the same side of the transversal is 180 degree, then the lines will be parallel. This is the converse. What will be the converse of this theorem? If pair of alternate interior angles are equal to each other when there are two lines being cut by a transversal, in that case, when parallel pair of alternate interior angles are equal to each other, then the lines will be parallel for sure. Similarly, the converse of this will be that if corresponding pair of corresponding angles are equal, in case when two lines are being cut by a transversal, then those two lines will surely be parallel. So these converses also hold true. Now, let us try to solve some questions here. We are given the question that, let's see, let the lines L1 and L2 be parallel and T be the transversal, find the value of X. So clearly we can see this angle and this angle, they form a pair of corresponding angles. So they will be equal to each other. Right? So that's what we are writing. And reason is corresponding angles are equal to each other. Okay. So from here we are going to get that x is equal to 3x minus 2x gives us x. 10 plus 20 gives us 30 degree. Okay, so x is equal to 30 is our answer. Correct? So here also we have the same solution, that these two angles are corresponding angles, so they are equal. Finally, solving the equation, we get the value of x as 30. Now, let us see another one, another concept, lines parallel to the same line. Okay, if two or more lines which are parallel to the same line, then they will also be parallel to each other. How can we prove this? It's actually very easy. Even in the chapter of postulates, introduction to Euclid geometry, there also we had done this proof using Playfair's axiom. Now once again we will do this proof. This time we will do it using corresponding angles. Okay, so what we are saying is that if in the postulates chapter we had done it using contradiction and using Playfair's axiom, but right now let us do it using corresponding angles, etc. Okay, So let us say there is a line L1, there is a line L2, there is a line L3, and it is given that L2, L3 both are parallel to L1. We don't, and we have to prove that L2 and L3 will also be parallel to themselves. So how can we do that? Let's draw a transversal here. So if this angle is alpha, this angle will also be alpha because L1 and L2 are parallel, right? So corresponding angles will be equal. Now this alpha will also be equal to this alpha because L3 and L1 are also parallel, and therefore these pair of corresponding angles will also be equal. So if this is alpha, this will also be alpha, correct? Now observe that for these two lines L2 and L3 being cut by a transversal, their pair of corresponding angles are equal because both of them are alpha, right? So since they are equal, by the converse of the axiom, we can say that whenever two lines are being cut by a transversal and corresponding pairs of angles are equal, then we can say that the lines will be parallel to each other, and hence we can conclude that line 2, L2 and L3 will be parallel to each other. And of course, this will hold for any number of lines. Here I have just taken 3 lines, okay? Consider the following figure in which L1 and L2 are parallel lines. We have to find this given angle X, okay? So how do we do that? Let us see. Let us redraw this diagram here. L1, L2 and 120 degree. Then 60 degree is given here, and let's say this point is C. Now from Playfair's axiom that we studied in the introduction to Euclid geometry chapter, we know that a unique line can be drawn from a point C which is outside, which is not lying on the line, which is parallel to a given line. So we know that using Playfair's axiom, we can draw a unique line passing through C and parallel to L2, right? And since L1 is also parallel to L2, L3 by construction is parallel to L2, from just the previous concept we can say that all of these three will be parallel to themselves because L1 is also parallel to L2 given, L3 is also parallel to L2 by construction. So L1 and L3 will also be parallel to each other using the last concept that we saw. Now since that is the case, let us call this angle as alpha, and this angle will be 60 degree only. Why will it be 60 degree? Because both of these form a pair of, they are alternate interior angles, pair of alternate interior angles, okay? Or we can also say like this, let us say if this angle is gamma, then gamma and 60 degree form a pair of alternate interior angles, okay? So they will be equal to each other because the lines are parallel, okay? So using the theorem, we can say gamma would be equal to 60 degree because reason is L2 parallel to L3, and whenever there are two parallel lines, alternate interior angles will be equal to each other, right? Now similarly, we also know that sum of interior angles on the same side of the transversal is equal to 180 degree. So if this is a transversal here, these two are parallel lines L1 and L3. These are interior angles on the same side of the transversal, then their sum must come out to be 180 degree. What is the reason? We have already seen the theorem that sum of interior angles on the same side of the transversal will be equal to 180 degree as long as the two lines are parallel to each other, which is obviously true. L1 and L3 are parallel to each other, right? So from here, alpha comes out to be 180 degree minus 120 degree, which is 60 degree, right? So what will be this angle X? X is clearly equal to alpha plus gamma, right? Because this angle plus this angle will give us this complete angle, correct? So that's why this comes out to be 60 degree plus 60 degree equal to 120 degree, which is our final correct answer. Fine. So I hope this example is clear to everyone. Okay. So let us see the solution as well. The same solution here, that angle x equal to angle beta equal to 60 degree, because they are alternate interior angles and the lines are parallel. As we have drawn already the construction, this line is parallel to both L1 and L2. Gamma is equal to 180 minus 120, because they are co-interior angles, or we can say interior angles on the same side of the transversal, and hence gamma also, or angle y also, comes out to be 60 degree. So angle C will be the sum of both these angles, which comes out to be 120 degree, as we also obtained. Now let us see some practice questions here. Question here is, these are two parallel lines and one L2, and there's a transversal. Find the value of x. So I will just give you a hint here. What kind of angles are they? What pairs of angles are they? Hint. They are actually interior angles on same side of transversal. So now think about it and tell me, whenever there are interior angles on the same side of the transversal, what was the theorem that we learned? Recall that and try to solve it. Okay. Second question we have. Consider the following figure in which AX and CY are parallel to each other. What is the value of angle B? Correct. So this is a little bit good question. So I will tell you how to do it. What we have to do is, first we need to do a construction. What will that construction be? From point B, construct a line which is parallel to AX. Okay, so if we, by using Playfair's axiom, we know that this can always be done. So I have constructed a line passing through B which is parallel to AX. And since AX and CY are also parallel, so these two will also be parallel, using the concept that we studied here. Correct. Now, what will this angle be? Let's see this angle. This will be 180 degree minus 110, which is 70 degree. Why is that so? Because obviously this is acting as a transversal, and sum of angles on the interior angles on the same side of the transversal will be equal to 180 degree for parallel lines. So clearly both of these angles lie on the same side of the transversal only, left side. These are parallel also, so their sum must be 180 degree, and 110 plus what angle will give us 180 degree? 70 degree only. Similarly, what will this angle be? It will be 40 degree, because this is acting as the transversal, these two are the parallel lines, and these are interior angles on the same side of the transversal, in this case the right hand side. Correct. So their sum will also be 180 degree, because these are parallel lines and we have already studied the theorem. So 140 degree plus what angle will give us 180 degree? 40 degree only. So what is this angle B going to be? Let us say angle beta. Since all these angles are lying on a straight line, we can say 70 degree plus beta plus 40 degree will be equal to 180 degree. What is the reason? Because if there are any number of angles on a straight line, then sum of all these angles will give us this entire angle. And the entire angle's value on a straight line is obviously 180 degree, a straight angle. Okay, so beta comes out to be how much? 70 plus 40 will be 110 degree, and 180 degree minus 110 degree will be 70 degree, which will be the answer. Fine. So that's how this question will be done, by using a construction. So, and yeah, of course, there is another way to solve. By using this construction also we can solve. Once again, we'll get the same answer. Correct? 70 degree only. Both of these solutions are absolutely correct. So thanks a lot for watching, and I hope you enjoyed watching the lecture and got to learn something new. Stay safe and enjoy your studies. Thanks a lot for watching once again. Bye-bye.